Find Z and H parameters, hybrid parameters for the network shown in figure. So in this dependent source is there, three meshes are there. So first you have to write direction in the two-port network. I am telling again and again, in the two-port network, if you remember, this is the direction, I1 direction, and this is I2 direction. So you have to retain this. So that's why it is clockwise. This is anti-clockwise. I2 should be like this. A middle mesh you write I3 clockwise only. So there's a dependent voltage source whose value depends on I1. This 4I1 means it is a current dependent voltage source. So normal procedure is write KVL for mesh 1, write KVL for mesh 2. You will get in terms of I1 and I3. Here also you're going to get in terms of I2 and I3. But Z parameter equations are V1 and V2 are expressed in terms of I1 and I2, not I3. So you have to eliminate that I3 term. Okay. By writing KVL for mesh 3, get expression for I3 and substitute it in equation number 1 and 2 and compare with standard equation, and you can easily find out. For all the problems for Z parameters, if they have three meshes, write KVL for mesh 1, write KVL for mesh 2, you will get I3 term also. How to remove this I3 term means write KVL for mesh 3, get expression for I3, substitute in equation number 1 and 2. Okay, you can easily solve. So apply KVL for mesh 1. Before that, I'll write polarity here. Plus here, let me consider plus here, minus here, plus minus. This is already voltage source. I2, I3 direction is plus minus plus minus. This is C, I2, it is clockwise. So this is plus, this is minus, this is plus, this is minus. Please observe in 2, plus 2 minus, plus 2 minus. These two I2 and I3 will get added. Here it is subtraction. Okay, apply KVL for mesh 1. Apply KVL, Kirchhoff voltage law for mesh 1. So V1 minus to plus, no? Or you can remember this voltage will be equal to this voltage. Plus to minus V1 is there, no? That is equal to 2 into I1 plus 2 into I1 minus I3. 2 into I1, okay? 2 into I1 plus 2 into I1 I3. That is, I explained like this. This voltage should be equal to parallel voltage. In this parallel voltage, 2 and 3, 2 and this 2 will come. Into only one current I1. In this two currents I1 minus I3. So that is written. Or if you are writing normal, okay, if you are writing normal, start from V1 minus V1 will come plus 2 into I1 plus 2 into I1 minus I3. This is going to give you same answer of this. This minus, if you bring it to right side, it is same as this one only. 2I1 plus 2I1 minus I3. 2I1 plus 2I1 is 4I1 minus 2I3. This is equation number 1. I want V1 in terms of I1 and I2, not I3. So I have to eliminate this I3. Similarly, apply KVL for mesh 2. Okay. This voltage will be equal to sum of this voltage. This voltage should be equal to sum of this voltage. In this voltage, 2I2, 2I2 plus 2 into I2 plus I3. 2I2 plus 2 into I2 plus I3. Why it is plus means I3 direction, I2 direction, plus 2 minus, both are downwards only. But in the opposite here, I1 is coming down, I3 is going up. That's why in the above we took opposite. But for this, in the two-port network, in the mesh analysis, all we are considering clockwise. But in the two-port network, we are derived expression by considering I2 towards the node. So you have to consider this and you have to write anti-clockwise only intentionally. And V2 is equal to, if I write KVL 2I2 plus 2I2 plus I3, you write from starting from this minus, same expression only you are going to get. So V2 is equal to 4I2 plus 2I3. So it's equation again here also unwanted term is I3. So how to eliminate I3? Write KVL for mesh 3. So start from 2. Okay, start from 2. You can use you can use minus second term. Okay, while writing this is second, minus is there, no? Minus second is minus, second one is minus. You can use this one or starting plus plus. So they used actually second minus, that is they consider fall as negative. Okay, this fall as negative, minus to plus they'll consider as positive. So this is if you're confusing, you can write this is plus, this is also plus, this is also plus. So 2 into I3 minus I1, 2 into I3 minus I1, this is already voltage source, plus 4I1 plus 2 into I3 plus I2, both are positive because it is direction of I3 and I2 are same. And simplifying this, you are going to get, okay, uh, 2I3 minus 2I1 plus 4I1 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 plus 2I3 plus 2I2. You make on notes while you are seeing the video, watching the video, so that you'll understand, because normally they are given direct answers, you will not understand steps. So you have to get the expression for I3. Okay, this 2I3 you written this side only, this 2I3. Okay, this is all are having two terms, so you can divide throughout by 2, you can divide throughout by 2, no problem, or without that also you can do. Is 4I3, 4I3, you bring this 2I1 plus 4I1 plus 4 minus 2 is, this is plus 4, this is minus, this is 2I1 you left, 2I1 if you bring right side becomes 2I1 minus 2I1, and this is minus 2I, and I3 is equal to minus 2I1 minus 2I2 by 4. It is 2 ones are 2 to 0. We'll get minus 1 by 2 I1 minus 1 by 2 I2. This is the value of I3. This value you have to substitute in equation number 1 and 3. This is same as this one only. Minus 2I3 is I1 plus I2. Minus 2I3 is I1 plus I2. I3 is equal to minus of I1 minus of I2. Okay. This is same as this. I3 value is minus of I1 minus of I2. And you have to substitute the value of this I3 value in equation number 1 and 2 above I written, no, corner. That if you substitute, you will end with V1 and V2 in terms of I1 and I2. So V1 and V2 in terms of I1 and I2. So comparing with standard equation, Z11 is 5, Z12 is 1, Z21 is minus 1, Z22 is 3. So these are the Z parameter equation. So it is very easy. I'll repeat once again how to do this. And its units are ohms. Write KVL for mesh 1, write KVL for mesh 2, you'll get unknown term I3. How to remove this unwanted term I3 is write KVL for mesh 3, get expression for I3, substitute it in 1 and 2, you'll get only V1 and V2 in terms of I1 and I2. We eliminated I3 because we substitute the value of I3, which is having the term I1 and I2. So finally we got, and for this problem we have to find H parameters also, that you have to obtain using a conversion formula. H in terms of Z. Okay, H in terms of Z, you refer my video how to transfer, how to obtain H parameter in terms of Z, and you can find the formulas and all the values are available. Delta Z means the determinant of this Z matrix. 5 into 3 minus 1 into minus 1. Determinant is 16, and the H11 is delta Z by Z22, which is 16 by Z22 is 3. H12 is Z12 by Z22. H21 is minus Z21 by Z22, and H22 is 1 by Z22. You refer my video H parameters in terms of Z parameters. If you don't remember this, okay, you can in the rough sheet you can try that you can obtain within 5 minutes, and you can use that values here. Okay, thank you.